Good morning, students. Today I want to take a revision class on completely miscible liquid mixers in solution chapter. This is very important concept and you already know in completely miscible liquid mixers, ideal solutions, non-ideal solution, azeotropic mixer concepts are very important. Now, you already know that solution means solute plus solvent, and it is defined as a homogeneous mixture of two or more substances whose composition may be varied within certain limits. Otherwise, supersaturated solutions, saturated solutions or unsaturated solutions will be formed. And larger component in the solution is called solvent. Lesser component in the solution is called solution. And you already know that solute and solvent may be exist in solid, liquid and gaseous states. Suppose if a solvent is a solid, solute may be solid, liquid and gaseous state. So there are three types of solutions are formed. In the similar way, if liquid is a solvent, the solute may be solid, liquid and gaseous state. So again, three types of solutions are formed. Listen carefully. If gas is a solvent, then the solute may be solid, liquid and gaseous states. Again, three types of solutions are formed. That means 9 types of solutions are formed. Out of 9, now we are studying liquid in liquid solution. So, solution of liquid in liquid. Depending upon the relative solubility of a liquid in another liquid, the liquid mixer may be classified into 3 types. Solubility. You already know that. Suppose if you take A is a liquid and B is another liquid, and B is added to A. B is almost dissolved in the other liquid. Then you can say that it is a completely miscible liquid mixer. Some liquids are partially soluble in liquids. Such type of liquid mixers are called partially miscible liquid mixers. Some liquid does not dissolve in any other liquid. Such type of solutions are called completely immiscible liquid mixers. Completely miscible. Now we are studying completely miscible liquid mixers. These are further classified into 2 types: ideal solutions and non-ideal solution. Ideal solution. You already know that ideal solution of two liquids is said to be ideal if each component of the solution obeys Raoult's law at all temperatures and all concentrations. For example, benzene, toluene, and another example, chlorobenzene, bromobenzene. What are the characteristics of an ideal solution? And I already told that ideal solution means which obeys Raoult's law. So in a liquid mixers, 2 liquids are there. Each component should obey Raoult's law at all concentrations and temperatures. And during the formation of an ideal solution, the total volume of a liquid mixer is always equal to the sum of the volume of the components mixed. Suppose if A is a liquid and B is another liquid, the total volume is V. Then V is equal to liquid A, volume of liquid A plus volume of liquid B. Or otherwise, the difference, liquid delta V mixer, is always 0. And during the formation of ideal solution, no heat is evolved and absorbed. That means the enthalpy value always 0. Delta H is equal to 0. And then what is Raoult's law? There are so many definitions in Raoult's law, but here The partial vapor pressure of any volatile component in the solution of at given temperature is equal to the mole fraction of the component in the solution multiplied by vapor pressure of the component in the pure state at the same temperature. Here this Raoult's law is a mathematical statement, and you already know that what are volatile liquids which can easily volatilized or which can easily vaporized. Such type of components are called volatile components. Consider an ideal solution made by mixing Na moles of liquid A and Nb moles of liquid B. Then according to Raoult's law, partial vapor pressure of one component is always equal to mole fraction of that component multiplied by the vapor pressure of pure component. Therefore, PA is equal to XA multiplied by PA. So here capital PA represents the vapor pressure of pure component. Okay, and XA is equal to mole fraction of A in solution, and PA is equal to partial vapor pressure of A. Similarly, the another component PB is equal to XB into PB. And according to the Dalton partial pressure law, the total vapor pressure of the solution is always equal to the sum of the partial pressures of the components, though here P is equal to PA plus P. And if you draw a graph between partial pressure of each component of each pure liquid and the composition of the liquid mixer will be straight line passing through the origin. I already explained in the classroom. You please see your notes. And some solutions does not obey non-Raoult's law. Such type of solutions are called non-ideal solution. Suppose if anybody asks you what are ideal solutions and what are non-ideal solution. Ideal solution means which obeys Raoult's law. Non-ideal solutions which do not obey Raoult's law. A non-ideal solution is that which does not obey Raoult's law, and during its formation there is a change in volume and enthalpy. And I already previously I told that in the formation of ideal solution no heat is evolved and no heat is absorbed, and the total volume is always equal to the sum of the volumes of the components. But here delta V mix is not equal to 0 and delta H enthalpy mixer is not equal to 0. And I already told that let us consider a solution formed by mixing the two liquids A and B, and the interactions of A and B molecules, that means AB, are not similar to those of pure AA and pure BB. In the formation of ideal solution, the AB interactions are always equal to AA or BB. But here, the AB interactions are not equal to AA and BB. In non-ideal solutions, suppose if you draw a graph between vapor pressure and the composition of a liquid, you will get a curved line. Whereas in ideal solution, you will get a straight line passing through the origin. That is the difference. And again, non-ideal solutions are two types. Non-ideal solution with positive deviation and non-ideal solution with negative deviation. Coming to the first case, non-ideal solution with positive deviation. Here, the AB interactions are weaker than those of AA and BB. My dear students, weaker means which can easily volatilized. That means which can easily vaporized. Suppose if you take an ethyl alcohol is one component and water is another component, after adding water and alcohol, that mixer can easily vaporize when compared to water and alcohol. Such type of solutions are called non-ideal solution with positive deviation. Then the tendency of the molecules of AB escape from the mixer. That means they are weaker. That means they become volatilized and is easily vaporized. That is more than that of the pure liquid. This increases the total pressure of the solution. So volatile compounds have high vapor pressures and low boiling point. Remember this point is very important, and here the delta V mix is positive and the delta H, the enthalpy value, is also positive. And acetone ethyl alcohol, okay, and ethyl alcohol water. Then the next case, non-ideal solution with negative deviation. And here the AB interactions are greater than those of AA and BB. Then the tendency of molecules AB escape from the mixer is less than that of pure liquids. That means here, suppose if you take one component is nitric acid and the other component is H2O, after adding the AB interactions, that means these molecules are not easily vaporized. That means this decreases the total vapor pressure of the solution. And here the delta V mixer is always negative and the delta H mixer is always negative. And you already know that, and water and acid adding, the heat is evolved. That means the enthalpy value is always negative. And these two cases in non-ideal solutions are very important, which are also studied in azeotropic mixers. So you please understand these concepts and read well. Thank you and see you again. Thank you.